Okay, so we've been studying graphing by transformation. We did a Desmos activity, and today I wanted to take some time to do that on paper and pencil mostly, but trying to clarify a few things about that, especially for people that were absent. So I wanted to start by just going back to here and just looking at a random function right here. So let's imagine this is my function f of x. And we've spent a little bit of time on this, and I hope everybody is feeling fairly comfortable with the idea that if we took f of x like this thing right here, and we chose to put like, say, a +4 out here, we should see a new graph that is congruent to the original graph, but moved up 4 units. And so you'll notice that that's the same idea there. And similarly, if inside we put something like a -3, that should move the graph to the right 3. Let me go ahead and change colors here so it's distinct from the original graph. Or, we have all sorts of little things that we can do in here. But where the stuff starts to get a little more complicated is what happens when we have extra pieces that are not simply addition and subtraction based. Like, for example, if instead of doing that, I say put a 2 in front, that's going to multiply all the y values by 2. So you'll notice we have this nice little value, originally 0, 4. If I put a 2 in front, that 0, 4 should land up here at 0, 8. That's kind of its translated point. Notice this one right here, which is at 6, 4 is now at 6, 8. And so we're going to be studying some of those little things. So keep in mind that anytime anything happens on the outside of the graph, it's just going to be changing the y values that are playing with it. But anytime things happen on the inside, it's going to affect the x values. So notice if I divided by 2, it actually ends up making the x values larger by 2 times. So notice this was a -4 and now it's a -8. It used to be at a positive, see the end of this little wing right here, used to be at +8 and now it's out here at +16. So we're going to just look at a few problems on paper to show how I would go through that process for a test or something like that. So let's go ahead and look at a document camera. And this is the notes that I did in class. So notice I have my 5 points that seem to indicate what is happening for this particular graph. And I've got 2 things that are happening. The first one is this 5 right here should affect all of the y values simply by moving them up, down 5. Whereas this value right here that is sitting on the 2, that x, that's going to be right here. And so I kind of do a little bit of an assembly line approach to make life a little bit easier. And this is going to transform it to a new A, new B, C, and D, and E. And quite simply, everything that affects y is on the outside, and it's going to do exactly what it says. So I'm going to take all of these y guys down here, and I'm going to move them down 5 units. So I'm literally just going through each one of those things, and I'm subtracting 5 from them. Similarly, for x, I'm going to go ahead and do those, and I'm going to do the orange, but remember, anything on the inside, what we learned in our Desmos activity, does the opposite of what it says. So instead of multiplying the x by 2, I'm going to divide it by 2. So I'm just going to go in here and divide all of those x values by 2, and then I'm going to plot those points. So -2, -5 is down here. 0, -1 is here. So here's my new A and my new B and my new C. My new D is over here, and my new E is right here. Kind of got smashed together with my previous work, but there we go. And so we notice that this graph got contracted horizontally, like it got smashed in half and then moved down 5 units. Okay, now for the next one, I notice that I have this +2, which is going to, of course, take all of these original y values and move them up 2 units. There's not anything particularly interesting about those things. So it moved up a little bit. But this is the part where it's a little bit interesting because this says to multiply x by -1. And so I'm just going to tell you we're going to do the opposite of that. And I'm going to, instead of multiplying x by -1, I'm going to divide it by -1. So divide by -1, divide by -1. And I know many of you are going to say, but isn't that the same thing? And yes, it is, but I'm trying to be consistent. This multiply by 2, so I divided by 2. This says multiply by -1, so I divided by -1. And so here we go. So my old a is over here. My new a is up here. My old b is right here. My new b is up here. My new c is at -4, 2. Here's my new c. My new d is right in here, and my new e is out here. And what you'll notice is this is a reflection across the y-axis scooted up too. So you'll notice it's like the arm is going in the other direction. That's pretty straightforward and easy stuff. Now the last one is the trickiest of them all, because as it turns out, when you play with these problems, there's some strange little effects that actually can happen inside this parentheses. And so when we look at this right here, let's imagine that I decided to do something like a 2x plus 6. Now, it seems fairly obvious that people are going to say, well, it's going to move to the left 6, and it actually got cut in half. But when we actually look at the data on this one, that's actually not true. It got cut in half, but it didn't move over 6 units at all. In fact, it's easier if we go ahead and, come on in. It's easier if we factor this out a little bit and take that 2 out, and what you would find out is there's like a parentheses here and here, and we're going to make that a 3. And so what you can see now is it did get divided by 2 and moved to the left just 3, but not 6. So what I'm going to do is pause this for just a moment here, and then I'll be back with how to do that last problem. Okay, let's get back at that. So for our last little example right here, what we're going to do is just remember that we do not ever, as a rule, ever allow anything to be attached directly to x. And in this case, there is. The negative and the 1/2 is directly attached to it. So if I factor that out, keep in mind factoring is a fancy way of saying the word divide. And so if I divide the 1/2 out, I still have 1/2 x like I had, but now it's actually a -6. So there's actually the effect here is that all of the y values, let's start there first because that's the easiest. All of those y values, I don't think I lined this up well, but it's all right. So the first one, I'm going to multiply them by -1 and add 3. Multiply by -1 is -4, add 3. Multiply by -1, still 0, add 3. Multiply by -1 is -4, add 3. And of course, I did this one on purpose, so a lot of the values are the same, making it easier. But here's the trick part. So for all of the x values, instead of multiplying them by -1/2, I'm going to divide them by -1/2, and then I'm going to add 6. So -4 divided by -1/2 is actually 8. And then if I move to the right 6, I get 14. 0 divided by -1/2 is still 0, and I move to the right. 4 divided by -1/2 is actually -8, and I move to the right 6. 6 divided by -1/2 is -12, and I move to the right 6. Let me do that again. 6 be -12, and then to the right. And last 8 would be -16, and I move to the right, and that would be -10. And I'm not going to take the time to graph this one because it just won't even fit on my curve. But it became very fat because that 1/2 really stretched the x values out, and then, of course, even moved them further off the graph. So it's pretty far out there. And that is kind of how you graph by transformation in a more theoretical sense. So I will see you back in class. Hopefully this was helpful.